Bobcat 5600, code 314, battery voltage extremely low, code 322, battery voltage out of range low. Same battery, same panel, two different codes, and the difference tells you where to point your meter first. The 3 family is the battery family. There are 5 of them, and you'll know all 5 today. Straight from the factory table, 3.9 is battery voltage low. That's the one you'll meet most often. 310 is battery voltage high. 311 is battery voltage extremely high, and that one can cost you parts. 314 is battery voltage extremely low, and 322 is battery voltage out of range low. 2 say low, one says extremely low, one says out of range low. That's not sloppy wording. Before we spit them apart, you need to know what the controller is actually looking at. It isn't clipping a meter onto your battery posts. It reads the voltage that survives the trip to its connector. Cable, terminal, fuse, connector pin, ground strap. Every one of those takes a small cut on the way. So the panel doesn't measure your battery, it measures what's left of your battery by the time it arrives. That's why a battery that tests fine on the bench can still throw in 3 code all week. It's the group text you got an hour after everyone else. The message was fine, the path wasn't. Hold on to that, because it's why 2 of these 5 codes are wiring problems, not battery problems. Start with 3.9, factory meaning, word for word, battery voltage low, nothing more dramatic than that. The controller sees less than it wants, but the number is still believable. Something real is sagging. Cheapest cause. First, always. The terminals, green fuzz on the post, a nut you can turn with your fingers. Pull them off, wire brush both the post and the clamp, and torque them back down properly. Next cheapest, the ground strap from battery to frame, and the strap from frame to engine. Grounds fail quietly. The strap looks fine from outside, and under the crimp it's powdered green. Then the belt. Blazed or loose, and the alternator spins slow under load, and under charges all shift. Now it gets pricier. A battery with a weak cell reads okay resting, then collapses the second it works. Then the alternator or its regulator, not keeping up with lights, cooling fan and hydraulics together. Worst case for 3.9 is a chafed harness, or a controller reading its own supply wrong. Here's the check that sorts every one of those in about 5 minutes, with 1 meter. Measure at the battery posts, key off, write it down, start the machine, measure the same posts again. Now compare those numbers to what the panel is reporting. That comparison is the entire diagnosis. If the posts read healthy and the panel still cries low, the battery is innocent, the path is guilty. If the posts read low too and climb once it's running, you're chasing a battery or charging fault. That comparison saves people from buying batteries they never needed. That's exactly what this channel is for. Stick around. Now 314, battery voltage extremely low. Same subject as 3.9, but a much harder hit. This is the reading you get when the system dunks, cranking, or a battery that's genuinely flat. A starter pulls hard enough that a tire battery drags the whole machine's voltage down for a second. The controller catches that dip, logs 314, and you find it later with everything running perfectly fine. So check when it's set. A code that only appears at crank is telling you about the crank. Cheapest fixes here. Repeat. Terminals, then grounds, then a proper load test on the battery itself. The load test is the honest one. Resting voltage lies like a phone at 1%, still showing a screen. Next rung up cables. A cable can look perfect and be corroded to green powder inside its insulation. You find that with a voltage drop test, and it's the most underused test in the whole trade. Meter across the connection, not to ground, while the circuit is working. You're measuring what that connection steals. A clean cable steals almost nothing. A bad one shows real voltage sitting across a piece of copper. Worst case, for 314, a dead cell, a starter dragging huge current, or a short pulling the system down. And now the one that catches people out. 322, battery voltage out of range low. Read that wording again. Not low. Out of range low. The panel isn't saying weak, it's saying impossible. That's a different complaint entirely. It's the difference between a short reply and no reply at all. A reading below what the circuit could physically produce usually means the circuit isn't producing anything. Open wire, broken pin, a connector backed out of its housing, a path that simply isn't there anymore. So on 322, put the battery down. Go straight to the connectors and the feeds at the controller. I'll be straight with you. The manual gives you these meanings. It doesn't publish a legend for the suffix digits. So don't drag a rule from one code family into another. Read the wording for the exact code you have. But habit alone puts you ahead of most people guessing in a yard with a phone flashlight. Cheapest check for 322, unplug it. Inspect the pins, look for green, look for one pushed back. Then wiggle. Backprobe the connector, watch the meter, and move the harness section by hand. A number that jumps while you're moving the loom, just named the exact foot of wire to fix. Worst case is a rub-through harness behind a pivot, or the controller. That's the expensive end of the list. Now flip the whole thing over. 310, battery voltage high. The system is pushing out more than it should. Almost always, that's the charging side. A regulator that quit regulating and just keeps shoving current in. But cheapest first, honestly, a bad ground can fool a regulator into overcorrecting. Check grounds before condemning anything. Then the alternator's sense wire. Only after those do you start pricing an alternator or regulator. Don't shrug off 310. Overcharging cooks a battery, boils it dry, and eventually takes electronics with it. The check is simple. Meter on the posts, engine running, and watch what happens as you bring the revs up. A charging system that keeps climbing and never settles is telling you the regulator has stopped doing its job. Which brings us to the last one. This is the code you never want to see twice. 311, battery voltage extremely high. Factory wording, exactly that. This one damages things while you're reading it. Classic way to earn it. A jump pack on the wrong setting, or a boost from a higher voltage system. The other classic is pulling a battery terminal off while the engine runs to see if the alternator holds. Don't do that on a machine full of controllers. The regulator loses its reference and the spike goes hunting. So if 311 shows up right after somebody helped you jump it, ask how they hooked it up. Same order of checks: grounds, sense wire, then regulator. But with 311, also inspect what it took with it. One more code lives right next door and it explains the faults you can never reproduce in the shop. 3128, interrupted power failure. That's the machine telling you power too. The controller blinked out completely. Blinked, not sagged. That's a loose connection making and breaking, and it'll set random codes forever. Chase that one with the wiggle test and the voltage drop test. Nothing shows up sitting still. Here's your ranked order for every 3 code, cheapest to worst, and it barely changes between them. Terminals, grounds, belt, connectors and pins, battery under load, cables, alternator and regulator, harness, controller. Controller last. It's the most expensive part in that chain, and the least likely thing that actually failed. So, low means real and weak. Extremely low means it dumped. Out of range low means the reading can't be true. High and extremely high both point to the charging side, and 311 means go looking for collateral damage. If you keep one thing, compare the panel's number to your meter at the posts. That's where it splits. The exact meanings and specs are in the service manual, linked below, like this, if it saved you a guess. Subscribe for daily diagnostics. Next up, the 4 family, engine oil pressure, and the code that shuts you down.